Okay, greetings, geometry students. I am going to be teaching your lesson today. It is 9.6, solving right triangles. So we're going to put everything together. It shouldn't be hard, we just got to figure out how we use when and how to take all the parts that we've done through triangles, and this will be what we're going to do to close out our time working with triangles. But of course I have to start, it wouldn't be right if I didn't start things off the right way. So I went to one of those battery stores in the mall, and I said I need a battery so that I can tell the time. And the assistant there, he goes, "Is it 4 o'clock?" And I'm like, "I don't know, that's what I need a battery for." Yes, groan, roll your eyes, and we're moving on. I love that one though. Do you get it? Jordan, this is for you. He asked if it's 4 o'clock, and I thought he meant is it 4 o'clock? And I said, that's what I need a battery for, so I knew what time it was. Just for Jordan. All right. So, this topic, as you can see on the board, 9.6, solving right triangles. What this means is, you're going to use all of the information that we've gone through in order to determine the lengths of all three sides of the triangle and the measures of all the angles of the triangle. All right? So let me drop down and get started. Here's what you will learn to use. You will use inverse trigonometric ratios and then solve right triangles. So first thing here in this example, identifying angles from trigonometric ratios. So it says here, determine which of the two acute angles has a cosine of 0.5. All right, so we have this triangle here. Which of these, which of the two acute angles, angle A or angle B, has a cosine of 0.5? A couple of things to lay the groundwork for this. First of all, I'm going to put this back up on the board. So Katoa, are you guys using that now, Emma, in your, you passed that?
I use it.
You use it, right? So Katoa. So if we're talking about cosine, cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So this question asks us, determine which of the two acute angles has a cosine of 0.5. So which of those two has an adjacent on top and a hypotenuse on the bottom that gives itself 1.5 as a decimal? Hopefully you can clearly see 1 over 2 is 1/2, which is 0.5. So the cosine would be angle B. Angle B, the adjacent is here, the hypotenuse is here, so the cosine of angle B is 0.5. Okay? So it says down here, they also found the other one, the cosine of angle A. Let me slide it up a little bit. Cosine of angle A is square root of 3, which is the adjacent, over 2, which they converted to a decimal 0.8660. And then, of course, here's your cosine of B, which is 0.5. Okay? I'm not worried about this, you know that off the top of your head, but here's what it says. If the measure of an acute angle is 60 degrees, then it has a cosine of 0.5. So if you come to this triangle and you say, okay, the cosine of B is 1 over 2, which is 0.5, then because it's a special right triangle, they're saying you should know maybe that's 60 degrees. But you can use your calculator for that as well. And that's what we're going to learn right here. So this is the next thing we're learning in our calculators. It is the inverse trigonometric ratios. And I have hinted at this when it comes time to use your calculator. All of you have your calculator that says tan, sine, and cosine. Now, all of your calculators then also have a secondary feature, okay? And it has a little -1, like that. That's called the inverse trigonometric ratio. And basically what that means is you're going to do the reverse of what we've done. You're going to take a decimal that you're given and plug it into your calculator inverse function, and then it will give you the degree measure of that angle. All right, so let's just take a look at it. So as you can see here, inverse tangent, if tangent A equals x, then tangent inverse of A, or if x is the measure of angle A. I'm not going to repeat that, that's very obvious. It's better if we just get started working in this. So example 2 says, let angle A, B, and C be acute angles. Use a calculator to approximate the measures of those three angles to the nearest tenth of a degree. So here's what you do. Look at angle, here, letter A. tangent A equals 0.75. So pull out your calculator, find the inverse tangent button, tangent -1. I see mine here, so put tangent -1 and put 0.75 and hit enter. And you all should get, if we round it to the nearest tenth of a degree, right, the inverse tangent of 0.75 is 36.9 degrees. What that means is angle A is 36.9 degrees. All right, so all you've done is you've been given the ratio and you've reversed it back out, so now you know the angle measure. In what we've been doing, you were given the angle measure, hitting tangent and getting that 4 decimal number. Now we're just reversing it. Now you've been given the decimal number, you use the inverse function, and you arrive at the angle measure, which is more valuable with what we want to know, right? All right, so the second one says the sine of B equals 0.87. So we want to know what that angle measure is. So again, I'll do it up here, it's higher. Now we're going to do the inverse sine of 0.87. So put that into your calculator. Okay, you're looking for sine -1. And then put 0.87, hit enter, and you should get 60.5 is the measure of angle B. All right, and lastly, we're given that the cosine of C equals 0.15, so we do the exact same thing we've been doing. We do the inverse cosine of 0.15, and you get, look for cosine -1, 0.15, enter, 81.4 degrees, okay? And that equals angle C. So again, the whole point of the inverse is you're taking the decimal and backing it out and getting the angle measure for that particular angle of the triangle. All right, so now, here's what we're going to do. We're going to do this in 2 parts because, okay, yeah, so we'll do the first part here. So we're going to have you should have your boards out. You're going to do this. Numbers 1 and 2. Let me slide it up. It says, determine which of the 2 acute angles has the trigonometric ratio as you see there. Okay? The sine of the angle is 12/13, or the tangent of the angle is 5/12. So, teacher, at this point, please pause the video so that the students can work this out on their boards. Give them, I don't know, 3 or 4 minutes, and then come and hit play back on the video. All right, now we're back. So the first thing asks you for the sine of the angle is 12/13. Let me write that on the board. So the triangle looks like so, 5, 12, and 13. We want to get to where it says the sine equals 12/13. Okay, which means the opposite over the hypotenuse. Right, because of so. And let's see, this is angle E, D, and F. So which of those angles, E or F, has a sine that is 12/13? Well, if I look at E, sine of E, the opposite of E is 12/13. Right, where the sine of F is 5/13. Okay, so the answer, which angle is the sine that gives you 12/13, is angle E. Sine of E opens up opposite to 12 over the hypotenuse of 13. The second one asks you for the tangent. Okay, which angle gives you the tangent ratio of 5/12? And remember, our tangent is TOA, opposite over adjacent. So the opposite angle is, or the opposite side is 5, the adjacent side is 12. So if I look back at my triangle and say which angle has 5 as its opposite, it's angle F. Okay? So the tangent of F equals opposite over adjacent. 5/12, which is what we wanted. So the answer for both of those is angle F. All right. Next part of this work for you to do is this. Let GH and K be acute angles. Use a calculator to approximate the measures of GH and K to the nearest tenth of a degree. So again, now on this section, I'm going to pause here. You're going to use your inverse functions to arrive at this answer. So a teacher, instructor, go ahead and pause here. All right. So number 3 says the tangent of G is 0.43. So what you should have put in there is inverse tangent, which is tangent -1, 0.43, and you get rounded to the nearest tenth, 23.3 degrees. Make sure you have the degree unit assigned, 23.3 degrees. Number 4 says the sine of h equals 0.68, so I'm going to do the inverse sine, the sine -1, 0.68. That gives you 42.8 degrees. 42.8. And lastly, cosine of k is 0.94, so I'm doing inverse cosine, 0.94, enter, 19.9 degrees. Okay, so those are very easy, that's just calculator work. Alright, now we move on to the next topic, solving right triangles. To solve a right triangle means to find all unknown side lengths and angle measures. You can solve a right triangle when you know either of the following. If you know 2 side lengths, or you know 1 side length and 1 angle measure of the acute angles. So here's our practice example. Solve this triangle. Okay, solve this triangle. So let me redraw this triangle here. And this, 2, 3, and C. Alright, so they gave us 2 sides. So the first thing that's easiest to solve for is the third side. What am I going to do to solve for the third side? I'm going to pick on Miss Alvarez, who's helping me today. Emma, how am I going to solve for C?
Pythagorean's theorem.
Pythagorean's theorem. Very good. Pythagorean's theorem. Of course, just a quick reminder of what Pythagorean's theorem is. You all should already know this. A squared plus B squared equals C squared. Where's, oh, this should be a right angle, by the way. My hypotenuse, hopefully you all recall that it's being pointed to. C is the hypotenuse. So I do 3 squared plus 2 squared equals C squared. 9 plus 4 equals 13. Sorry, that's not, well, that is right. 9, and so then I equals C squared, sorry. 13 equals C squared. And so to arrive at C, I do the square root of 13, and C equals 13 square root. I did it backwards, 1 second. .6. Okay? So I found the length of the hypotenuse 3.6. I feel okay with that answer. I'll confirm it here. The reason I said I feel okay is because I was solving for the hypotenuse. It better be longer than the other 2 sides, which it is. And in the book, it is 3.6. Now, we need to solve for the angles, because to solve the triangle means to solve for all 3 sides and all 3 angles. And so this is angle A, this is angle B. So now I use my trigonometry to find the angle measure. And I don't care which one. I'm going to use angle A, and I'm going to use tangent. You could use any one you want. You can go tangent, sine, cosine of A, or tangent, sine, or cosine of B and arrive at your answer. I'm choosing this because it's going to give you a nice easy decimal to work with, right? Because tangent of A, let me erase this. Tangent of A, TOA, is opposite, which is 3, over adjacent, which is 2, okay? And that equals 1.5. So tangent of A is 1.5. If I want to know what degree measure that is, though, now I use the inverse tangent function. So go to tangent inverse, tangent -1, 1.5, and I get 56. So the inverse tangent is 56.3 degrees. Okay, now, once you're to this point, I have two angles solved. You don't need to do trigonometry now to solve this angle. Think much easier than that. What is the easiest way, Emma, to solve this now?
To add it all to 180.
Right. Remember, there's 180 degrees total in every triangle. I know this is 90. I know this is 56.3. So if I go 90 plus 56.3, I get 146.3 degrees. And so then I just go 180 minus that, and I get 33.7 degrees for angle B. I did that math right? I did. Let me make sure it conforms with the book. And it does. Okay? So notice what we used there, y'all. We used all things we've learned about triangles. I used Pythagorean's theorem to find the hypotenuse. I used trigonometry to find the missing angle, and then I used the thing I always told you, the most basic thing to never forget about any triangles, they all add up to 180 degrees to get the last angle. Okay? So your answers for this would be 3.6 is the length of the hypotenuse, 56.3 degrees and 33.7 degrees are the two angle measures for angle A and angle B. Good. Your turn. Solve these triangles. Okay, so again, instructor, this would be where you would pause. Pause. Okay, pause and solve these triangles. So go ahead and do that now while I erase. All right. So I'm going to draw the first triangle, DFE, D, F, and E, angle here, 21 and 20. We're going to do Pythagorean's theorem to solve for the hypotenuse. 20 squared, use the other calculator. 20 squared, 20 squared plus 21 squared equals, and then
There's a glare there.
a glare on the TV.
On the screen, on the board. If you could draw like more in the middle, it'd be easier for them to see.
I wonder, maybe reverse the blinds. And I'm going to do the square root of that while Emma's fixing the blind situation. 29. Is that better or no?
No.
Is it the other one? No, it is that one, right? All right, well, anyway, 29 is the hypotenuse. It was a nice whole number. We'll do the best we can. The sun came out.
That's better.
So it's better, okay. So I've got the hypotenuse is 29. Now I'm solving for these angles. So I'm going to use, it doesn't matter now because the numbers are what they are. I'm going to do tangent of E. And you may have done something else. As long as you get the same answer, it's okay. Tangent of E is opposite 20 over adjacent 21. Okay, and that is 20 divided by 21. That's 0.9524. Now I'm going to inverse that, inverse tangent that. 0.9524. Ugh. And I'm getting 43.6 degrees. Okay, so the inverse tangent gave me 43.6 degrees for angle E. And just quickly taking that, it's complementary to angle D. So subtract 90 minus 43.6, and I get 46.4 degrees. Okay, that's the first one. All right, second one. So I have GJH, right angle 91. And here notice, one thing they did a little different. I've told you, please, the first thing you should identify in any of these triangles is the hypotenuse. Please notice they gave us 109 as the hypotenuse. So now I have to use Pythagorean still, but instead of a squared plus b squared equals c squared, I do the c squared minus a squared equals b squared, because they gave me the hypotenuse. So it's 109 squared minus 91 squared equals b squared. Okay? And let's see what that gives me. squared minus 91 squared is 3600 equals b squared. So now I square root that, and that's 60, I believe. Yep, b equals 60. Isn't that nice? They give you nice whole numbers to work with. How thoughtful. All right, so gj length is 60. At any point, by the way, I should have said this earlier, at any point if somebody has a question, please pause the camera so that you can talk through it with each other. All right, so now I just need to solve for the two angles. These numbers are all hideous, so I'm gonna pick something besides tangent. I'm gonna take angle G, and I'm gonna do cosine. Cosine of G. Adjacent, 60, over hypotenuse, 109. Put that into my calculator. 60 divided by 109. I get 0.5505. Alright, and so then to solve for the degree, I do the inverse, the cosine -1 of that decimal. So secondary cosine 0.5505, 56.6 degrees. So angle G is 56.6 degrees, which means that angle H, 90 minus that, is 33.4 degrees. And there's your answer for those two problems for you to work on. All right, let's move on in the lesson. Solving a right triangle. All right, now this is slightly different, okay? Here is where they gave you, instead of giving you two side lengths, they gave you one side length and 1 degree. And that's fine. We can still solve for it, not a big deal. So let me erase and draw. Add my triangle. HJG. Right angle, this is 25 degrees, this is 13, G and H. Okay. So I need to solve for the other sides. Well, Emma, what's my first and easiest thing to solve for?
Angle G.
Angle G, right? If I know this is 90 and this is 25, clearly this is 65 degrees. Let's do that first. That's easy. Okay? 90 minus 25. Now, solving for little g, little h, the side lengths. You can use, they gave me the hypotenuse, so with SOHCAHTOA, that means I'm going to use sine and cosine, because they both have the h for hypotenuse. So sine of 25 equals opposite, which is h, over hypotenuse, which is 13. H is on top, so I multiply. 13 times the sine of 25. Okay, 13 times the sine of 25 gives me 5.5. Right, so this equals 5.5. Now, at this point, I can now use Pythagorean's theorem again if I want to. I can square this minus this squared and do the square root, but I'm going to use trigonometry. It's probably easier. So now I'm going to look at 65. We're solving for h. So I'm going to go cosine of 65 degrees. Oh, I'm not solving for h, sorry. I'm solving for g. I am solving for h. Did I write that? Oh, I wrote that wrong. Ah, there, I'm confusing myself. And I probably confused you. Sorry. Just solve for h. H is 5.5. Now I need to solve for g. I'm going to stick using angle h. So if I'm solving for g with angle h, this side is the adjacent side. So cosine, 25 degrees, equals adjacent, which is what I'm solving for, over the hypotenuse. Again, variables on top, I'm going to multiply by 13. 13 times by cosine 25, 11.8. Okay, and that's all you do. Just confirming both of these numbers should be smaller than the hypotenuse, and they are. So I feel pretty good about that answer. Okay, hopefully I'm not wrong. You know me, I don't ever make mistakes. Okay, good, we've got that solved. And you can't argue with me here. And Emma won't, even though she thinks differently. Okay, So, oh, they didn't give you yours to work on yet. I almost want you to work on one first. Let's do that first before I do the word problem. Look at number 8, please. I'm going to break it down first and then go back to the word problem. So number 8, solve that triangle to the right. Triangle XYZ. Solve. Find, oh, there it is. Okay, find the 2 remaining side measures and the angle measure. Go ahead and pause the camera now, or pause the tape. Don't pause the camera. Sorry. Pause the tape so you can work on it now, please. All right, so we have our triangle, XYZ, okay, 8.5, and this is 52 degrees. So the first thing you should be very quickly figuring out is the other angle. 90 minus 52 means this is 38 degrees. Okay, so now I want to solve for this side and this side, the hypotenuse. I have 52 degrees, I have the adjacent. So I'm either going to use cosine or tangent because they both have the A for adjacent. We'll start with cosine. Cosine, let me call these A and B. Cosine of 52 degrees equals adjacent, which is 8.5, over hypotenuse, what I'm solving for. Now the letters in the bottom, so we divide. Flip-flop these. A equals 8.5 divided by cosine 52 degrees. Okay, and that is 8.5 divided by cosine 52, 13.8 is the hypotenuse. And then the other side, I'm going to use tangent. So we go tangent 52 degrees equals adjacent 8.5. I'm sorry, I did that backwards. Tangent of 52 degrees equals opposite, which is what we're solving for, over adjacent 8.5. Letters on top, I'm going to multiply. 8.5 times the tangent of 52 degrees. And that is 10.9. Okay? And again, it at least checks out that my 2 side lengths are less than my hypotenuse. So the answers here are 38 degrees, 10.9 for one side, and the hypotenuse of 13.8, and that's solving the right triangle. Last thing is this word problem. Your school is building a raked stage. The stage will be 30 feet long from front to back with a total rise of 2 feet. You want the rake, or what they call the rake, to be the angle of elevation to be 5 degrees or less for safety. Is the raked stage within your desired range? So this, we look here. Okay, the raked stage just means they're going to make it in a slightly elevated or slanted stage. They do this so that those in the audience can have a better view of everybody that's behind others in the back, right? So, what they're saying is they want this angle X to be less than 5 degrees or less. And so they go, what about with these specifications? I have this right triangle here. 30 feet represents what, Emma, in this triangle? What does 30 feet represent in this triangle?
The hypotenuse.
The hypotenuse is the right answer. And we know that this leg is 2 feet long. What is this leg in relation to this angle? It's opposite. So opposite leg, hypotenuse, we are clearly working with sine. Okay, sine is opposite over hypotenuse. So we take this, sine of angle X equals 2 over 30 equals 1 over 15 as a decimal. 1 divided by 15 equals 0.0667. So now to figure out what degree that is, I now do the inverse sine of that. Sine -1. So 0.0667 sine negative, I did it backwards. Sine -1, 0.0667. And I get 3.8 degrees. Is that 5 degrees or less? It is. So this proposed stage construction of a 2-foot rise in the back, sloping down 30 feet, is within acceptable norms. The last thing here says, suppose another rake stage is 20 feet long with a total rise of 2 feet. Is that raked stage within your desired range? Okay, so instead of 30 feet long, it's 20 feet long. Pause now and calculate it out. All right, we're back now. So now I'm just going to change this really quickly because I'm running out of time. Wait a second. Okay, so now it's 2 over 20, which is 1 over 10, which is 0.1000. So now I do the inverse sine of that. Okay, so sine -1 of 0.1, and I get 5.7 degrees. So now we have violated our principle. We've gone above 5 degrees, so that will not work. A 2-foot rise with only a 20-foot stage is not acceptable. That's the end of the lesson. You can rewatch it as you need to figure out what you need to do, but at this point we've covered all about solving right triangles. Good luck.